So section 3.5, derivatives of trigonometric functions. So in this section we're going to find the derivative of trig function. So trigonometric function means it's a sine function, cosine function, and then rest of the function like cosecant, secant, tangent, cotangent. So first of all, if you try to find out the rate of change of sine function, then you will find that is cosine function. Okay. Similarly, the derivative of cosine function is negative of sine function. So these are the two things you have to remember. Derivative of sine is cosine and derivative of cosine is sine. You can prove this by using a limit definition. Okay. So by using limit definition, you can find out this information. And by using these two formula, we can derive formula for tangent, secant, cotangent, and cosecant. So after this point, just write it down, write down this formula a couple of times, and it will be helpful for you when solving the problem in this section. Okay, so the first question is find out the derivative of y with respect to x. So as you can see that y is cube root of x times cosecant x. So make sure that this is cosecant x and plus 9. So to find the derivative, you need to find the derivative of this part, which can be found by using product rule. And when you try to use the product rule, if you remember, if y equal f times c, then dy over dx can be found by using product rule, which is derivative of the first function times second function plus first function times the derivative of second function. So in this case, we have the first function is f of x is it's a cube root of x, which is x to the power 1/3, and g of x is it's a cosecant of x, cosecant of x. So we need to find out the derivative of this function, which can be found by using power rule, which is 1/3 times x to the power 1/3 minus 1, which is negative 2/3. So eventually we can write it down like 1/3 x to the power 2/3. And the derivative of cosecant function, if you go back to that table here, you can see that the derivative of cosecant is negative cosecant times cotangent. So the derivative of this function is negative cosecant times cotangent. So we are going to use these values f, f prime, g, and g prime in this formula, and then that will help us to find the derivative. So f prime, which is 1 over 3x to the power 2/3 times g of x, which is cosecant of x, plus f, which is x to the power 1/3 times g prime of x, which is negative cosecant x times cotangent x. Okay, so you can just write it down as it is, or you can just simplify if it's simplify if you can simplify it. So this is cosecant x over 3x to the power 2/3 minus x 1/3 times cosecant x cotangent x. So you can go one step further and you can just make the one denominator, or just leave as it is. It depends on what instruction you have given in the problem. Okay, but that is the derivative. Let's look at another problem where we need to find out the derivative of trig function. So the equation here we have given is the position function. So position function of an object can be modeled by using this function 4 minus 9 times cosecant t. And now we need to find out its velocity, speed, acceleration, and jerk. So from previous section, we can say that velocity can be found by finding the derivative of position function. Speed means it's a absolute value of the velocity. Whatever we find here, just make it positive. And acceleration, which is basically it's a double derivative of position function. And finally, this jerk is it's a triple derivative of this position function. So we need to find out the derivative of this initial function 3 times. And we need to find out all this information when time t is pi over 4. Okay, so let's do that. Velocity, let me write it down. Velocity as v, acceleration as a, speed as, this speed, and jerk as j. Okay, it's j. So v is the derivative of 4, which is 0, minus 9 times derivative of cosine function. If we go back here and see the formula, the derivative of cosine function is negative of sine. So this is a negative of sine t, which is eventually negative times negative is positive times sine t. That's the velocity. Now we can find out the velocity at t, when t is pi over 4. We can always do that. Okay, velocity when time t equal pi over 4 can be found by using this formula sine pi over 4. So which is, I think it's 1 over square root of 2. So we can use the calculator, or just write it down like this: 9 over square root of 2, or 9 square root of 2 over 2. If you rationalize, if you just try to get rid of this radical from the denominator, you can write it down like this, or you can use calculator for finding the decimal form. So that's the velocity when time is pi over 4. So if you want to find out the speed, in this case, speed and velocity, they are same because it's a positive. So speed, this is absolute value of 9 sine t, but the value of the function, sine function at pi over t is positive. So speed at t equal pi over 4 is the same thing because it's a positive value, 9 times the square root of 2 over 2. After that, we have to find the acceleration, which is derivative of this, which is 9 times a derivative of sine function. And as we know that derivative of sine function is cosine function, so this is just 9 times cosine function. So if we want to find out acceleration when time is pi over 4, we need to just find 9 times cosine pi over 4, which is basically same thing because sine pi over 4 and cosine pi over 4, that is same value. So it's basically same value. And jerk j is again derivative of this one, which is negative 9 sine t, because derivative of cosine t is negative. Okay, so that will give us uh, j at pi over 4 when time is pi over 4 is negative 9 times the square root of 2 over 2. This is the only thing which is negative. So there is another example here. So let's look at the problem. A weight is attached. So this is the weight. It is attached with the spring here, and reaches its equilibrium position. If we because of this weight, it goes down and it reaches the equilibrium position. The equilibrium position means this is the height we can measure, and equilibrium position means when the x is 0. This is equilibrium position. This position is the equilibrium position. It is then set in motion, resulting in displacement of x equal 4 cosine t. So because of this weight, this spring goes down, and then it goes to the state of motion, and this motion can be modeled by using this function x equal 4 cosine t, meaning the displacement of this spring, displacement means change in position of this spring, can be modeled by using this function 4 times cosine t, where t is time. So here this displacement is measured in centimeter and time is measured in second. So by using this information and this picture, we need to answer some question. The first question is, what is the spring displacement? Displacement means what is the value of x when time is 0. So when time is 0, the value of x when time is 0 is just use 4 cosine 0. So which is 4 cosine 0 means it's a 1, which is 4. So when time is 0, the equilibrium position x equal 4. So that means here, this is the starting point. Okay, that's a displacement. That's the first question. The second question is, what is the spring displacement when time is pi over 3? Displacement means always use this function x equal 4 times cosine pi over 3. It is 4 times cosine pi over 3 is it's a 1 over 2, so it's a 2. Okay, so that's 2. What is the spring velocity? So to find out the velocity, this is the position function displacement. So find out the velocity. Velocity is the derivative of this displacement with respect to time, which is 4 times the derivative of cosine t is negative sine t. So this is if you want to find out the velocity when time is 0, we need to put t equal to 0 here, which is negative sine 0, which is actually 0 because sine 0 is 0. So the velocity when time is 0, when starting point, the velocity of this spring is 0. That makes sense. Now we need to find out the velocity when time is pi over 3. So as you can see that this is the velocity, which is negative 4 sine t. So velocity is negative 4 sine t. We would like to find out the velocity when time is pi over 3, which is negative 4 sine pi over 3. So the value of sine pi over 3, which is square root of 3 over 2, which is basically negative 2 times the square root of 3. So when time is pi over 3, the velocity is negative. So that means this spring is going, going down. This is negative. It's going down. Okay. So that's the section. That's the derivative of trigonometric function.